Absorption coefficient. Different surfaces have different range of absorption of sound energy. This extent of absorption is characterized by quantity called absorption coefficient. An open window can completely transfer sound wave incident on it, so that an open window is considered to be a perfect absorber. So the absorption coefficient are measured in terms of open window unit. The absorption coefficient alpha of a surface is defined as the ratio between sound energy absorbed by the surface to the sound energy absorbed by an equal area of a perfect absorber. Sabine is the unit of sound absorption, and the total absorption is given by sum over area into the absorption coefficient. Reverberation. In a hall, the sounds produced by a source can be reflected from walls, floor, ceiling, etc. So, in addition to the generated sound, there will be reflected sound as well. And this can happen, this can give a persistence of sound, that is, sound going on even after the generation is stopped. This is called reverberation, and this reverberation decays exponentially to zero with time. So, if there are more absorbing materials inside the hall, the decay time can be reduced. And the interval of time required for the intensity of this sound to reduce to 1 by 1 millionth of its original value is called reverberation time. So, IF, final value of intensity, equal to 10 raised to minus 6 into I initial. So, II by AF equal to 10 raised to 6. So, in decibel unit, initial decibel unit is 10 log II by I standard. Final is 10 log IF by I standard. And the difference between initial and final is given by 60 decibel. So, in other words, reverberation time for a whole is the time required for the intensity to drop by 60 decibel. Sabine's formula for reverberation time relate between reverberation time T, volume of the hall V, the area S, and the absorption coefficient alpha, given by T equal to 0.167 V by alpha S, or 0.167 V by sum over alpha I Si. If there are more surfaces, then each surface area into the absorption coefficient of the particular surface. So the reverberation time is proportional to the volume of the hall and inversely proportional to the total absorption as well as the total area of sound absorbing surfaces. For example, dimensions of an auditorium are 60 meter by 15 meter by 10 meter, and its interior surfaces have an average absorption coefficient of 0.25. Find the reverberation time of the auditorium. So it's find out by using the expression 0.167 by alpha s, 167 b by alpha s, and substituting the value we have 1.745 second. And find the reverberation time if 500 people are present, each having an average absorption of 4.5 sabines. So T is again carried out or measured by using the expression 0.167 into B by alpha S. So this is the uh, um, alpha S of auditorium, and this is the alpha S of people present. So we have a reverberation time of 0.47 second. Architecture acoustics and the factors affecting as well as the remedies. So in an acoustically well designed hall, the sound produced, whether it be speech or music, anything, it should reach every point in the hall with the required audibility and die away at appropriate time. So what are the factors affecting this particular property, particular necessity? And we will see one by one. One is reverberation. That is, for good acoustics, the reverberation time should be neither too small nor too large. That is, if the reverberation time is too small, what happens? The loudness will be inadequate and the sound will dies very faster when a very short time. That is, sound won't be reaching far away, and the hall will be called a dead hall. And when the reverberation time is too large, That means the sound persists for long time even after the generation, and it will overlap with the successive sounds. So that means the clarity is lost. So the reverberation time must be approximate, and this is optimum value referred as optimal reverberation time, which can be calculated using Sabine's formula. So how do we control the reverberation time? Using windows open and everything, so that to uh, keep the reverberation time optimum. And having the audience per capacity inside the hole, as all human beings are good absorbers, lining the walls with good absorbers like fiber boards, glass wool, etc. Using thick curtains or covering the floors with carpets, providing suitable sound absorbers, extra sound absorbers on the wall as well. Second is focusing surface. If there are focusing surfaces present inside the hall, then what happens is the concentration of sound reaching some areas will be less than the other areas. So the reflected waves may combine with the direct waves and produce stationary waves. So for a uniform distribution of sound energy, we have to avoid the focusing surfaces or the curved surfaces, and we have to keep the ceiling at a low value as well, low level as well. We can use a parabolic sh- shaped podium, and that way the sound wave generated at the podium can get reflected and reach the audience in a uniform fashion. Third one is sufficient loudness. An average person can detect a sound of 30 decibel at 1000 hertz. However, 13 decibel sound at 50 hertz is very difficult to be heard. So for satisfactory hearing, sufficient loudness is important. That can be arranged by setting loudspeakers at successive intervals. Again, using low ceilings for suitable shape to increase the probability of reflection of sound wave towards the audience, like this, and using large sounding boards behind the speaker to increase the possibility of reflecting back and the uniform distribution of the sound waves. And there is absence of echoes. The way echoes is present, it can cause confusion. So for good hearing, echo can be avoided by covering the walls and the as well as the ceiling. Resonance also can harm the quality of the sound propagated inside the hole. So interference from the sound wave, some forced oscillation can happen. If we dampen this oscillations happening due to certain materials inside the hole. For example, air inside can cause resonance, so which need to be damped. There is also echelon effect. That is, if there are reflecting surfaces at a regular interval spacing, it can produce additional notes by regular succession of echoes. This can make the original sound unintelligible. That is, the quality of the sound is reduced. So, such surfaces at regular reflecting surfaces at regular interval should be avoided or covered with absorbers.